Hello students, welcome back to our channel Maths Infinity. I am Dr. Kaushik Sarkar and today we are going to discuss a problem on quadratic equation. Actually this problem is for Maths Olympiad, but this problem have been asked in many competitive exam in different formats. So this question is very important for especially JEE, mains and advanced and for ISI. So first look at the problem and then try yourself and then I will help you to solve this. First look at this problem. If the coefficients of the quadratic equation px square plus qx plus r is equal to 0 are odd integers, then the roots of the equation cannot be rational number, irrational number, imaginary number and none of this. Okay. So for the root of this equation, first we solve this in general method. So x equal to minus q plus root over q square minus 4pr by 2p. This is Sridharacharya method. Now this part is called discriminant of this equation. D equals to q square minus 4pr. Okay. Now in order to find if we want this root to be rational, this d discriminant must be of the form a perfect square. Okay. Now it is given that p q r are both odd numbers. Okay. And we know that this is a property of number theory. It's a simple property that square of a odd number is of the form 8k plus 1. Just look at this thing. 3 is a odd number. 3 square is equal to 9. It can be written as 8 into 1 plus 1. 5 is a odd number. Its square is 25. It can be written as 8 into 3 plus 1. 7 is a odd number. Its square is 49, which can be written as 8 into 6 plus 1. So as we can see, this is a property actually of number theory. So the square of a odd number can be written in the form of 8k plus 1. So since q is a odd number, we can write q square in the form 8k plus 1 where k is an integer. Okay. Now another thing, p is also an odd and r is also an odd number. So product of two odd number is always a odd number, and we know that a odd number can be written in the form of 12 plus 1 or 12 minus 1. Okay, suppose this is 12 minus 1. Now we will see the discriminant. Just we put this value. So this is 8k plus 1 and 4 into 12 minus 1. So 8k plus 1 minus 8l plus 4. So this is 8 into k minus l plus 5. Now look, 8 into something, a number plus 5, which is always a odd number. Okay. We know that the square of a odd number is a odd number. So if d is to be a perfect square, then d must be of the form 8k plus 1. This is a contradiction, as we can see that d is of the form 8k plus 5. So this is a contradiction. Okay. So d cannot be a perfect square. So the roots cannot be rational. Okay. And another thing is that it may be possible. It may possible that q square minus 4 q square is less than 4pr. Then the roots become imaginary. So this is another option, may be true for some different values of PQR. So our correct option is D. The roots cannot be rational number.